Hello, my name is Donald Palomino, and I recently graduated with my master's in manufacturing engineering, and I am a fellow in ARCS. So when I first came to CSUN, I was doing a master's in mechanical engineering, and I wanted to do an emphasis in manufacturing engineering. However, I thought that in order to do manufacturing, you had to do mechanical. So I did an entire semester, wasn't too thrilled about it. And then one of the professors, Dr. Christoph Schall, recommended that if I really wanted to do manufacturing, there was a manufacturing program in CSUN. And I looked it up, and sure enough, there was a manufacturing program. And within 1 week, I transferred from mechanical to manufacturing, and I finished my education there. And the reason why I like manufacturing so much in the first place was just during my bachelor degree in aerospace engineering at CU Boulder, I really enjoyed 3D printing, or better known as additive manufacturing, and I wanted to explore that better. So I'm Peruvian American. Both of my parents were immigrants from Peru, which is a country on the west coast of South America. And I was a first generation college student thanks to their hard work and effort in providing me a good education. So since my parents have always pushed me to be the best I can in academics, they never really let me watch cartoons or things like that. They made me watch like National Geographic and Discovery at an early age. So since then, I sort of had I had a higher aptitude, I guess, towards like STEM subjects as opposed to my peers at that time. So it's a bit of a tricky question because I wouldn't say anyone actually inspired me to go to college. It was more of like societal norm that being that I already did high school, naturally the next step would be doing college because everyone else was doing that. I wouldn't say I have like some role model that I wanted to be like, or if there was any significant person close to me that said like you have to do college and things like that. It was just like sort of expected of me. So after I graduated my degree in aerospace, I came to CSUN to do my degree in first mechanical, then manufacturing engineering. And as I mentioned, Dr. Christoph Schall, who recommended me to manufacturing, he also said if you are interested in doing research in manufacturing, you should talk to Dr. Bingbing Li, who specializes in additive manufacturing. So once I transitioned majors, I also reached out to Dr. Bingbing Li if he has any student researcher positions available. He did, and so I worked at his laboratory, the LSAM Laboratory for Sustainable and Additive Manufacturing, and from there I transitioned into ARCS. So like I said earlier, because my early childhood comprised of me watching a lot of documentaries on National Geographic and Discovery Channel, the thing that fascinated me the most was space, just because of how unknown and almost eerie it was compared to all the other subjects. Later on, as an adult, I began to have more of an emphasis towards space because, you know, it's a cliche, but it's the final frontier. It's completely alien to us as humans, as terrestrial beings, and just how inspirational space travel is. I mean, if we look at aeronautics, planes, the reason why humans wanted to fly is because we watched birds fly and we wanted to emulate them. But nothing in our natural world goes to space. That was completely original by humans. That was born from human desire to do something beyond what the natural world allowed. ARCS has helped me a lot with my academic or career goals through my mentor, Dr. Bingbing Li, who has given me so many amazing opportunities, such as writing conference papers for the SFF conference in Austin, Texas, and also helping me get my internship with the NASA Goddard Space Flight Center during my fall and spring semesters. And that was an amazing internship because it exposed me to state-of-the-art technologies like generative design and also more conventional methods like anticipating manufacturing constraints during the initial design process. Those sort of experiences helped me a lot in becoming a better engineer. Yeah, so one of the biggest problems in engineering is the wall that divides manufacturers and engineers. Engineers can create these beautiful designs that are theoretically possible on the computer, but are feasibly impossible to actually manufacture, whether that be from CNC machining or 3D printing. And the problem is that engineers, when they're designing, they don't anticipate those manufacturing constraints in their design. So when they finish their design and they think they're done, they send it over to the manufacturers, who then look at it and say, we can't make this. This is impossible to make. And then they send it back to the engineers, who then have to do all these redesigns based on the manufacturer's notes. And it becomes almost like this game of tennis, this back and forth of passing this design to eventually create a realistically manufacturable design. Now, one of the biggest takeaways from my internship was being able to anticipate for these manufacturing constraints in the initial design process, so that when you eventually hand it off to the manufacturer, it's good to go. There's no back and forth necessary, and that can save a project months of time to completion. One of the best parts about ARCS for me was meeting like-minded people who are interested in STEAM like me, and people who are very hardworking individuals who inspire me to become a better engineer in my own right. So a major obstacle in my life that I had to overcome was when I tried to bite a lot more than I could feasibly chew. At a given moment during my time at CSUN, I was a full-time master's student. I was working as a full-time intern at the NASA Goddard Space Flight Center, and I was also a student researcher here at ARCS. Doing all three of those consumed a lot of my time, to the point that I found myself struggling to breathe for air. And how I overcame that was I had to acknowledge areas of my life that I had to sacrifice. So for example, I used to enjoy playing video games or watching TV shows. I basically had to throw those away to make time for my academics, work, and research. And as difficult as it was, it did make me a better engineer because I was able to have a more a schedule that I could consistently follow every single day, and that just made life a lot easier. I would say the most inspirational people in my life have been my parents, just as they were immigrants from another country coming to America at a time before internet, social media, things like that, which made it easy for them to connect with the world. They came to this country not speaking English, not knowing anyone here, not having money, and through hard work and dedication, they were able to make a very good lives for themselves here in LA. And that sort of hard-working ethic is something that I aspire to emulate. The best advice I can give to someone who's entering STEAM or an engineer is make sure that it's something that you're really passionate in, because engineering is a wonderful subject that really opens so many doors, answers so many questions about the universe, but it takes a lot of your time. It is soul-crushing to the point that it'll make you want to drop out. And it's only if you have passion will you be able to survive that. If you don't have that passion, you may be better off looking at another subject or degree. I know that's probably not very inspirational at all, but that's like, this I wouldn't want to keep in the interview, but I hated studying aerospace engineer at my undergraduate. It was so soul draining and time consuming, and I did not enjoy it, but I was already 3 years in, and I was like, might as well finish it up. The reason why I have such great passion for manufacturing is because it is the limiter to human creativity. As I mentioned earlier, where engineers can design these beautiful designs on a computer that may not be realistically manufacturable. That is ultimately the limiter, is can this be manufactured in the real world? Because there are some brilliant designs and concept arts that I have seen that unfortunately can never be brought to our world because of manufacturing restrictions. But I believe that if we push forward in manufacturing technologies, particularly additive manufacturing, so things like 3D printing, then we can begin to see more advanced technologies in our daily lives. We can start bringing ideas from science fiction to reality. And that is only through manufacturing. And that is why I want to make sure that I'm a part of it in some capacity. As I mentioned, engineering has been very difficult for me, especially with all the workload and different responsibilities that I had. But one of the best ways that I was able to overcome it was through the help of my support system, being my family and friends. They've always been supportive of my decisions and taking on so many responsibilities, and have always given me great advice, not necessarily as engineers because none of them are in STEM, but just in how to manage life in general and how to enjoy the smaller things, you know, how to stop and smell the roses, things like that. I would like to definitely thank Dr. Christoph Schall for being the one to guide me in this long journey in manufacturing engineering and ARCS. If it wasn't for his words of encouragement, I would have never been where I am today. I would have graduated with a degree in mechanical engineering, which I wouldn't have been too thrilled with. I would like to thank Dr. Bingbing Li for providing me with so many amazing opportunities, for giving me such critical feedback to becoming a better engineer and a better manufacturer. And I would like to thank Ryan McClelland from the NASA Goddard Flight Center for being such an amazing mentor, walking me through so many. Let me stop there with the Ryan McClelland. Can we edit that? Okay. And I would like to also thank Ryan McClelland for being such an amazing mentor in helping me learn manufacturing technologies, generative design, what it means to take these manufacturing constraints in the initial design process, and how to create high mass to stiffness ratio parts for spacecraft flight.
Well, Spot's excited, and so are we. Hope you enjoyed that video. Check out our social media here with links in the description. Make sure you like, follow, and subscribe. Hit that bell for notifications. Thank you.